Morning. So in this class, let us learn what an K-map or Karnaugh map is and how this K-map will be constructed, and then using this K-map, how the physics in the switching equation can be removed. Basically, in the earlier lectures, we have seen any given switching equation can be solved by removing the redundancies, by applying the Boolean laws, theorems, and rules. But when any given switching equation, when it is removed using or simplified using this Boolean laws or theorems or the rules, the process it is very lengthy. Hence, a better approach than the above method is your Karnaugh map. Basically, now we'll see how this K-map will be constructed and how this K-map, which is going to remove the redundancies, we will learn in this particular class. Karnaugh map is a matrix of squares, permits to identify the redundancies. And this K-map also identifies all the possible cases where the redundant information in the form of x plus x bar or x odd with x bar is 1. In K-map, if the switching equation contains the minterms, then 1 will be entered in the square of a corresponding cell. Suppose the switching equation is of max terms, then 0 will be entered into the corresponding square. So with this, now let us construct through a simple example how a K-map will be constructed for two variables. This Karnaugh map, it is also termed to be the K-map. When you are constructing this two variable K-map, two variables you can consider either as AB or XY, Z, X, any variable you can consider. So when such two variables K-map we have to construct, already we know that the K-map is a matrix representation of squares. During the two variable K-map representation, first we need to identify how many cells we will have in a K-map. So for that, consider the two variables. The number of variables in a given switching equation assumed to be two variables. So therefore, the number of cells in a K-map can be calculated as in K-map with respect to the given number of variables as 2 to the power of n, where this n is in the given two variable K-map, n is assumed to be 2. So therefore, the number of cells will be equal to 4. And all these 4 cells needs to be represented in the form of the matrix. So 4 cells when we are representing using the matrix, you can represent all the 4 cells as 2 cross 2 matrix. When this 2 cross 2 matrix, when it is observed, the number of cells, you can see that there are totally 4 cells. Yeah, each cell will be identified through a decimal number as 0, 1, 2, 3. This decimal number representation in a K-map will be represented with respect to each cell top left corner. And now each cell, since it represents in a K-map a min-term or a max term, how do this min-term or the max term will be identified? That is represented through the variables. Let two variables be A and B. So these two variables out of which identify which is the MSB bit and which is the LSB bit. Suppose we are taking two variables as A, B. Let me assume the A as MSB, A is in MSB position, B is in LSB bit position. So during the representation of these bits in the K-map, there are two methods you can adopt. The first method, for an K-map, vertically at the top left corner through a diagonal line, the variables can be represented as A, B. Below the diagonal line A, that is the MSB bit, and above the diagonal, the LSB bit. All the rows which are representing horizontally represents the variable A, and the columns in a two variable K-map represents the B variable. Since a single variable we have for the row representation as well as the for column representation, the possible values a variable can take is 0 or 1. So hence we are substituting the variable values 0 as well as 1 to each of the cell. The combination of these variable values represents the cell either with the min term or with the max term. Example, let us take an cell 0. Cell 0 represents which min term or which max term? Representing A is 0 for an cell 0, B is also 0. If cell 0 is representing min term, then this min term is the product of variables. The variable A and B, but both are 0, so therefore that represents A bar, B bar. Suppose if it is of max term, then that particular cell represents, that is cell 0. Okay, cell 0 represents the max term as A plus B. Similarly, cell 1 representing the min term A bar B, because the variable value to the row it is assigned is A, its value is 0, and the column value it is B as a value of 1, hence A bar B. Similarly, if the cell 2 is considered, A with B bar, cell 3 with A, B. When the max terms are represented, here cell 1 will be A plus B bar, cell 2 will be A bar hard with B, and cell 3 representing A bar odd with B bar. So if you look at these cell values, what are the various min terms it is representing? A bar, B bar. A bar B, A B bar, A B. Similarly, max terms A plus B bar, A bar plus B, then A bar plus B bar. So hence, all the min terms have been covered in the two variable K-map. Now let us see how a three variable K-map will be constructed. So to construct a three variable K-map, we will be finding the number of squares to be used in K-map. It is 2 to the power of 3, 8 cells. 8 cells we need to arrange in a matrix form, either using 3 columns, 2 rows, or 2 columns with 3 rows. Either of the way you can represent. But let me take the three variable K-map representation using the two variable column and one variable row. So in such case, total 8 cells I'll be representing using a matrix representation having 2 rows and 4 columns. To represent a 4 column, 2 variables are required, and those variables identification, for which let us consider the variables as ABC. In that, I'll be separating 2 variables for the columns. Those are the least significant variables, and the most significant variable I'll take it for the row to represent. So a single variable, so it is representing the 2 rows in a K-map as 0 and 1. The other 2 variables BC, they are representing the columns, and these values when we are placing, always we need to make use the gray code method. In a gray code, between one variable to another, one minterm to another minterm, there will be an minimum change of 1 bit. So therefore, we are using the gray code for this 2 bits, 0, 0, 0, 1. So if the adjacent cells have been considered and the redundancies are the way changes have been observed, B is common in both the cells, whereas C is changing. Similarly, when the next cell is considered, one variable has to change, so therefore 1, 1. The next one will be 1, 0. So in this way, the 4 cells K-map has been, 3 variable K-map has been constructed. The cell values in the 3 variable K-map are represented as 0, the first cell, second cell is 1, the fourth cell is 2, and the third cell is 3, 1, 2, 3, 4. Fifth cell, it is representing the cell value of 4, 5, 6, 7 based on the positional weights of bits. So this is how a K-map will be constructed in the So this K-map specifically we are using for the simplification of switching equations. Those switching equations either may be in the form of the sum of product terms, or it may be in the form of product of sum terms. So in the next class, I'll be continuing with that.